Hey guys, Matt Marzillo here. In this video, we're going to be going over another example of how to use the payment function or the PMT function in Microsoft Excel. So this is very similar to the auto loan example we had, but we're looking at paying off student loans, maybe something a little more relevant to all of us here. So what you have in front of you is you have three different rows of data that shows different ways of paying off a student loan. So obviously the periods per year, so you're going to be making monthly payments no matter if you're using the standard or one of the extended options. The interest rate's going to stay the same. The key difference is the duration, right? So whether or not you're going to try to pay it off in 10 years, 20 years, or 30 years. Okay? And then the value is obviously the same. You're starting off with 75. You're graduating from college and you have $75,000 of student loan debt. That's the starting point for each of the three different options. Future value is zero. It's always going to be zero when you're paying off a loan, right? You're shooting to pay it down to zero. And then I inserted a little formula here that just multiplies out the monthly payment by the annual payment, so you can kind of see how much you're paying on a yearly basis for each of these options. Just kind of another way to look at the information, the payment information. Okay, so with that, let's go ahead and get started. Most importantly, we have our data in a good format and a good setup. We just want to click on cell E4, make sure that's highlighted. Go up to the function bar here, this wizard. We already have the PMT functions right here at the top because we recently used it. Let's click on PMT, click OK, and let's just start kind of plugging in our arguments, right? So the first thing here is a rate. So we want the annual interest rate, so that's 6%, but we're calculating monthly payment, right? So we want to make sure we divide that interest rate by 12. Number of periods, so with this one, we're looking at 10 years, so that'll be D4 times 12, since we're looking at monthly payments. The present value is our starting point. That's $75,000 right here in cell F4. Our future value, we can just type in 0, I guess, or we can since we have it here, let's go ahead and just click G4, and that's it, right? We're going to leave type blank. So you can see here it's showing payments of $832.65 a month. Let's go ahead and click OK. Okay, so we're going to pay that much a month. That looks like a lot. And then we're also going to pay, close to right around $10,000 a year or so. So now, since we set up the referencing, that we're referencing the right cells, and we want to include relative cell referencing for all of these, right? We're not going to insert any dollar signs. We can simply just pull this formula down, and calculate it out for each of the different loan options here, whether we're doing 10, 20, or 30. So you can see how the monthly and annual payment amount goes down when you extend the period out a little bit longer, right? If you're trying to pay it off in 10 years, you're going to pay a lot more per month than if you're trying to pay it off in 30 years. Pretty simple math there, right? I mean, that's kind of intuitive. But let's look at the total payment amount. Let's just go ahead and plot down another formula here. I want to multiply this annual payment number by the duration in years number to understand how much I'm actually going to be paying, right? What's the total in dollars and cents? How much more am I paying for one of these options over the other? So we can simply do that by clicking equal sign. We're going to multiply that number in cell H4 by the duration in years. Click enter. Okay, so it's nearly $100,000. That seems about right. Yeah, so we're starting off with $75,000. There's some interest on there, so yeah. Okay, let's pull that down. Okay, now that's impactful, right? That's something good to know, right? It might be nice to only pay $450 a month as opposed to $832, but the total amount that you're paying, you're gonna be paying an extra, nearly $62,000 over the term of the loan if you push it out, an extra 20 years. Maybe you're better off kind of settling somewhere in the middle here and biting the bullet with the 537. This is just a nice kind of way to kind of lay out, in dollars and cents, how much a loan is going to cost you over the course of months, over the course of a year, and over the course of many years. Okay, guys, as always, feel free to shoot me an email or give me a call if you have any questions. The next video is me going over the future value function. Thanks a lot.